is done reader's theater style. It is not designed to be a full-blown play where everybody had to memorize their lines and have lots of props and costumes. The idea is to work on our word fluency and really tell the story. The art of storytelling in our world sometimes has gotten lost with the amount of electronics that we have. We can push a button and replay and get the same thing over and over and over again. As I was saying to the kids, the beauty of live theater is that every time we do it, it's different. And that's what keeps it exciting and fresh. We talked about the art of listening to the radio, listening to a radio play. How many of you kids have ever heard a radio play? Wow, that's a lot of you. Excellent. Well, as I was telling the kids, long before there was television, people would sit around and share stories from person to person. And then we had this great invention called radio. So again, we tell stories and we let everyone put their imagination into our story. The fun thing about our show today is we've learned a lot about numbers, haven't we? We have, and we're excited to tell it for you today. So we have lots of fun. I hope you will laugh, give lots of energy coming back to them. So, and they're all excited to tell their story in search of numbers. So without any further ado, ladies and gentlemen, Lee's third grade class presents for you In Search of Numbers.
Good day, everyone, and welcome to our Reader's Theater play titled In Search of Numbers. It's a story about the history of numbers. We're counting on you to sit back and be our audience for the show. Just a little math humor, friends.
Numbers are fascinating, and we use them every day. Cultures from around the world have developed their own number system. Many are still used today.
Let's face it, it all adds up.
Don't tell us more math humor, and now on with the show.
Hello and welcome to WBEC's TV series, You're Right There. Today we'll be looking at the history of numbers, where they came from and how we wanted to use them. Let's go to our on-the-scene reporter. Where are you?
I'm not sure. Far back in time, I think. All I see around here are goats. Wait, here come some goat herders. Hello there. I'm investigating numbers. What kind of numbers do you use? Numbers? Oh, we have very modern numbers.
We have the number 1 and the number more than 1.
That's not a lot of numbers.
It's fine for us. We don't have a lot of goats.
But how do you count the ones you have?
I have 1 goat. See how easy it is?
I have 1 and 1. So that's more than 1 goats.
No, I have 1 and 1 and 1. That's more than 1 goat.
Wait, I have 1 and 1 and 1 and 1 goats. I have more than 1 goats.
This is silly. You all have more than 1. You just need some new numbers. You have 1 and 1, right? We call that 2 goats. Look, I have 2 goats. And you have 1 and 1 and 1 goats. That's 3 goats.
1 and 1 and 1 make 3? How cool is that?
And I have 1 and 1 and 1 and 1 goats. How many goats do I have?
You have 4 goats. Now how many goats do you have altogether?
I know this. This is addition. 1 plus 2 plus 3 plus 4 makes more than 1. No, it makes 10.
Why don't we go count other things?
Let's go count chickens. We have lots of chickens. Thank you. Now we're in Samaria, which is ancient Iraq. It's about 5,000 years ago. Here are two Sumerian mathematicians. I understand that you have developed a number system, gentlemen.
Yes, it's based on the number 60.
We make a little notch for the number 1 and a dot for 10.
Here comes the good part. When we get to 60, we use a big notch.
Then we add more and more notches and dots. We can make any number we want.
So your number system is really just made up of notches and dots?
We have a very advanced number system.
It's a lot better than making marks on sticks.
Or scratching lines in dirt.
Excuse me, but we're Egyptians. We have a much number system than they do. What are they doing here? This is Samaria.
This kind of stuff happens all the time on TV.
As my friend was saying, in Egypt, we have a number system based on 10. Not based on 60 like the Sumerian system. After all, we have 10 fingers, not 60.
How does it work?
We have a line for 1 arch for 10, 10 lotus flowers for 1,000, and a frog for 100,000. You have a frog as a number? We like frogs in Egypt.
Just because you like something doesn't mean you have to make a number out of it.
Our number system is much more advanced than yours. 10 is better than 60.
Is not.
Things are getting out of hand here. Well, let's jump right ahead to Rome.
Okay, sorry about that. Here we are in Rome, about 2,000 years ago. They've developed a number system using letters. Let's ask one of these Roman mathematicians to explain it. Am I on TV?
Yes, you are.
Cool. So here's how our new number system works. For number 1, we use the letter I. Then for 5, we use a V. For 10, we use an X. And then an L for 50, C for 100, D for 500, and M for 1,000. This way we can make as big a number as we want. We're Romans. We'd never use notches or frogs or anything like that for our numbers. Okay, how would I write a big number like 3,273? 3 N's for 3,000. 2 C's for 200. An L for 50. 2 X's for 24. That's 70. And 3 I's make it 73. So the whole number is MMMCCLXXIII. Is that the best number system you've ever seen, or what? How do you add or multiply numbers with all those different letters in them? It takes a really long time. We make lots of mistakes. But we're working on it. Good. Keep doing that. Meanwhile, we're moving on. We're just about ready to develop our modern number system. Thank you. Here we are back in Iraq. We're in Baghdad, about 1,200 years ago. We're here to interview Muhammad Ibn Musa, better known as Al-Khwarizmi. Mr. Al-Khwarizmi, tell us about the new system of numbers you invented. Oh, we didn't invent it. It took many people and many centuries to develop.
It started with the Hindus of India almost 1,000 years ago.
They invented a system with symbols for each number 1 through 9.
Once you reach 9, you move over one place. We say the number's 10, but we write it with a 1 and a 0. That way, we can use the same symbols over and over again. Their value depends on what place they have in the number.
The Hindus also invented the number 0. It fills a place when you have no number to put there.
Couldn't tell the difference between 1 and 1 million without zeros.
That was very exciting, but we've done something beyond that.
We've developed a system for writing numbers so anyone in the world can learn them.
We call it the Arabic number system.
Didn't the Greeks also contribute to it? Oh, of course. It takes many minds to come up with a new idea. The Greeks came up with the word arithmetic.
Arithmos is the word for number, and technique means an art or skill.
Arithmetic takes a lot of skill. Any math student can tell you that. Well, we and the Hindus and the Greeks and many others have done now that people use numbers to solve problems.
I'm working on a new idea. It's called algebra. It's a way of using letters to stand for things we don't know. This will help us solve more difficult problems.
That's what we call algebra. You see how Khwarizmi, they will remember what we have done. Thank you both very much. We have only one more stop to make in our search of numbers.
Yes, here we are at the University of Pennsylvania in Philadelphia.
It's 1946, and we're here to see the world's first digital computer.
It's called the ENIAC. That stands for Electronic Numeral Integrator and Computer. It's so big it fills an entire huge room.
We're here with 4 computer scientists. We've been learning about number systems and what they have to do with the first computer. Computers use a very old system called binary numbers. It has just 2 numbers, 1 and 0.
The Hindus and the Al-Khwarizmi used it. The ancient Chinese used it. They call it yin and yang.
Every number can be made up of ones and zeros. We don't use ones, tens, and hundreds places. Binary numbers have places called ones, twos, fours, eights, and 16s, and so on.
Every number place is twice as big as the one before it.
Exactly, so our number 23 is 10111, 116, no 8s, 14, 12, and 11. 16 plus 4 plus 2 plus 1 is 23, see?
But all those ones and zeros must give you really long numbers. Yes, but computers love them. You see, computers run on electricity. And there are only 2 things you could do with electricity. Turn on or turn it off.
So that's how we tell a computer to do something.
We have lots of little circuits throughout the computer. We turn the electricity on and off to these circuits as fast as we want.
1 is on, 0 is off.
When you talk to a computer in ones and zeros, it will do anything you ask it to do.
Well, we're at the end of our journey.
We've gone from pebbles to notches to frogs to ones and zeros.
From Samaria to Egypt to Greece to Baghdad to Philadelphia.
So until next time, this is the You're Right There news team saying goodbye and learn those numbers. The end.
Ladies and gentlemen, before they leave, I'm a firm believer that all young people in theater or any other performance deserve a standing ovation. So, one more time, ladies and gentlemen. So much fun. They've learned the art of the bow. So, boys and girls, one more time. We go up, we sweep, we go up, and we smile. How much fun I've had working with them. Many of these children have been bit by the theater bug, and I am just thrilled in the next 5, 10 years to see where chance